Alright, so the last little part of the notes for this section says that we're going to use synthetic division to evaluate a polynomial. So we're using synthetic substitution. You know when you substitute, oh, I can't talk and spell at the same time, sorry. If you substitute a value in for x, then you're just evaluating a function at a given value for x, and that's really all this is. Instead of having to do something like, well, I'll just go down here and show you on this one. If I had, I'm going to scoot to the bottom right here. If I had this, I'm using the example 11 up there, and I said to find where x is 2, then I would be doing this, substituting in a 2 for x. And so I would have to do, oh my great balls of fire. Let me fix and smear. So I would be doing this. And it's not really that it's that hard, but we can do it kind of quick with this synthetic substitution. So the difference here that I want you to notice in this and the way it's set up and this is this has x plus or minus a number in parentheses. Over here, and we had to change the sign. Over here is telling you exactly what x is. So the difference in the substitution and division you do not change the sign. On the divisor. In other words, if that says x equals 2, then on the outside of my division, I'm going to put 2. If whatever it says, that's what you use. You do not change the sign if you're doing substitution. So here's all you do. I've got a 2x cubed, a 5x squared, a negative 1x, and a positive 7. It was in order, 3, 2, 1. Nothing was missing. So you do the same, just like you're doing division, except you don't change the sign. And the difference in what's going to happen here is in division, the remainder told me whether or not the thing that I had was a factor. Over here, my remainder is going to tell me something different. You do the same process. You slide down that first number, you multiply, drop it up here. 2 times 2 is 4, 5 plus 4 is 9. 2 times 9 is 18. Sorry. Negative 1 plus 18 is 17. Just put that up there. 2 times 17 is 34. And 34 plus 7 is 41. So here's what my remainder tells me here. I'm not trying to figure out if that's going to go into that. I want to know if x is that, then what's the value of that function? So this tells me that if I substitute in a 2 for x, my answer is 41. And that's really neat how that works. It just works, and I'm going to show you, if you don't believe me, real quick right here at the bottom where I did it. If I did 2 cubed, that gives me 8. 2 squared is 4. Minus 2 plus 7. So 2 times 8 gives me 16. And 5 times 4 is 20. Minus 2 plus 7. So now if I add those things, 16 and 20 gives me 36. And negative 2 plus 7 gives me a positive 5. And 36 and 5 is 41. And it's magic. So I can do this, or I can do this. And this is just a whole lot faster. You're still doing what you're already used to. You're making sure that it's in standard form. 3, 2, oh, there's not a 1. There's not an x to the first. So it's 1x cubed, 3x squared, 0x to the first, and 4. X is negative 3. Plug that in. And do the stuff. Bring down the first term. Multiply, drop it in. 3 minus 3 is 0. Multiply, negative 3 times 0 is 0. 0 plus 0 is 0. Negative 3 times 0 is 0. And 4 plus 0 is 4. So this tells me that if I plug in negative 3 into my function, my answer is 4. That's the value of that function when x is negative 3. Synthetic substitution. Evaluating a polynomial for the value of x that I've been given. Number 12. When x is negative 1/3. Check everything. I've got to the 4th, to the 3rd. I do not have an x squared, so I need a 0 for that. X to the 1st and positive 5. So, negative 1/3 goes on the outside. And I've got 6, negative 25, a 0x squared, negative 3, and 5. And let's get started. Bring down that first term. Negative 1/3 times 6. A third of 6 is 2, and since that's negative, that's going to make it negative 2. You can use your calculator if you don't like those fractions. Negative 25 and negative 2 gives me negative 27. And negative 1/3 times negative 27 is positive 9. 0 plus 9 is 9. Negative 1/3 of 9 is negative 3. Negative 3 and negative 3 is negative 6. And negative 1/3 of 6, negative 1/3 of negative 6 is positive 2. And 5 and 2 gives me 7. So that means that if I substitute negative 1/3 into x for my function, it gives me a value of 7. So if it's substitution, if it says use synthetic substitution to evaluate the polynomial, do not change the sign. If it says to use synthetic division, then you do change the sign on that divisor. So last one. My exponents are 2, 1, and a constant. X is equal to 1/5, so the 1/5 goes on the outside. I have a 5x squared, 9x, and 3. Bring down the 5. 1/5 of 5 is 1. If you don't believe me, use your calculator. 9 plus 1 is 10. 1/5 of 10 is 2. And 3 plus 2 is 5. And so if I were to evaluate my function, and I just did, for x equals 1/5, then p of 1/5, or the value of my function where x is 1/5, is 5. And that's all there is to synthetic substitution.